Hi everyone, good morning. Today we'll be starting new chapter permutation and combination. Since this chapter there are formulas, but the formulas are such that in every question you have to use different formula. The formulas will never be same in any condition. So I'll be taking some examples like questions and then I'll be telling you some tricks how to solve those kind of questions, and I just hope ki you'll be able to solve them because formulas are okay. There are 4 5 formulas, permutation, combination, and there are a lot of cases, right? You have to make cases and then automatically formula brings out of those cases. Like if it's a circle, then there will be cases that there are one together, two together, becoming one together, not taking one, excluding, including, this and that. So after every condition, as we have one condition, then a new formula gets born. So you cannot use just one, two, three, four, or 10 formulas in this chapter. There are lots of formulas. So we'll be going through type of questions and telling which kind of formula to use where and how to modify the formula according to the question. So without wasting much time, let's start with the very first formula principle, which is a principle of counting. This is also called multiplication principle because it's generally we multiply in this. Like if n different ways an operation is performed and another operation is performed m different ways, like two operations, then the probability, like the ways in which both the operations can be performed together, is m into n ways. For example, a gate, there was a hall, 10 gates were there, a man has to enter and then come out of a gate, but it should not be through a different gate. If he has went through one, then you have to come by a different gate. That's why he has to multiply 10 into 9, because now there are 9 ways of coming out, coming back again. And when we have been asked in which either of the two jobs is performed, what is the ways in which either of the thing can be done, in that condition we add, right? And like in multiplication theorem, it was when we meet both the requirements. But if we have just either one of the two requirements, then we have to use addition theorem. This is, so if one way to perform a job is m and to perform another job is n ways, then to perform either of the ways, either of any jobs, that is m plus n ways. Suppose there is a class in which there are 12 boys and 7 girls, and you want to the teacher wants to select a boy or a girl, then he will add it simply. 12 plus 7, 19 ways. The teacher can choose anyone from the 19 students. Factorial notation, you already know it. What is factorial? 1 factorial, 2 factorial, s till n factorial. So now we'll be starting some theorems. These theorems are the very basic things. Like with the help of these theorems, you will be able to establish modified techniques to solve the questions in the exam. So very first one, like if you have n different things, out of n you're taking r things at a time, then the ways to select that r item. Suppose you have l- like 4 numbers. Suppose you have 6 numbers and you have to select 4 numbers out of it. So in such a way that it is not repeated, then you will this one, then you will use npr, where n is the total number, like 6p, and then the number of the numbers you have to take, 4 numbers I have to take, so it will be 6p4, like that. So now the number of the permutations of n distinct things taken are at a time when repetition is allowed. It's like the first theorem. But if the repetition is allowed, then it becomes n ki power r. It's very simple. Okay, just go through it. Then we are coming to theorem 2, which is prove that npr is equals to this. It's very simple. npr is what? This you have to use directly. You have studied it in first theorem, that you will find it through NPR, but you know what is NPR. N factorial upon n minus r factorial is NPR. if you would have solved questions, because right now I'm doing just revision, so this you already know and I don't have to tell you everything. So yeah, just go through the chapter, just it's a revision only. So now we've reached to fourth theorem. Like we have n things and we're taking all at a time. Out of those n things, we have to select a thing in which p are alike of one kind, q are of another kind, and like that. So in that case, and p plus q should always be equal to n. If it is not there, then it will not be, we will not be able to do this. But we have to use a different formula which we will study in this one. So it will be n factorial upon p factorial and q factorial. But if we have to n things, we have to say one thing out of which k1 are alike, k2 are alike, k3 are all alike. That way, k1, k2, k3, they plus all equal to n, and that will be n factorial upon k1 factorial, k2 factorial upon k3 factorial. This very like simple thing. This is just the first one. Next part is this, the number of permutations under certain restrictions. Suppose we have the permutations of n different objects taken r at a time. Right, we're taking r out of n different objects. In that condition, like we are including one. So to be always included in each arrangement. Then it will become r into n minus 1 p r minus 1. This is r, don't forget it. People generally forget it, but it's not. The number of arrangements of taken different and different objects taken r at a time in a particular object is never taken in each arrangement is, it's never taken. Then it becomes n minus 1 p r. It's very simple, right? Because you're not, it's opposite. When it's included, then it's just negative. When it's again is excluded, then it is just r, there is no negative. The number of the permutations of n different objects taken at m is always come together. Like we had n different things, n1 n2 and like that, but there are m specified things which have to be always together, n1 n2 suppose will always be together. Then we have to consider these two as one rather than everyone. The n minus m, that will become n minus m things we will have. This ka factorial, right? That it will become. But there m is specified. M ko we can also keep it in one, like m ways. M factorial, right? If there are m things, then to arrange them also you need m factorial ways. That's why it's m factorial into n minus 1 plus m plus 1 factorial. Number of permutations of n different objects taken all at a time in m specified x could never come together. They are never coming together. So it will be, instead of m factorial, it will be n factorial minus m factorial. This is of coming together. So definitely this will be n factorial, that was the complete, and of not coming together, n minus this whole, that is this is n and this is whole minus, we are subtracting it out of it. Simple. Next part is the circular permutations. When we have our objects put up in a circular way, then we use these formulas. It's different then. Suppose like this is n objects are there and it is a circle, like n1 n2 n3 like that to n. Then the number of ways we can put these objects, we can arrange them. Permutation means arrangement. So the number of ways in which we can do arrangement of these stuffs is called the circular permutation. That is n minus 1 factorial. If there are n objects, then we can have it n minus 1 factorial. Yeah, and sometimes we will put it up such that when we go anti-clockwise, it will be same. But when we go clockwise, it will be different. So when it is same, in that condition, when both the anti-clockwise and clockwise is same, then we can use it this, because then we have to divide it by 2 because both things are same. Arrangement is the same whether you take anti-clockwise or clockwise. And if you are taking clockwise and anti-clockwise is different, then you will have n minus 1 factorial. Simple. If the circular permutation n different things in which we have to take only r things out of it. And we have to take that clockwise and anti-clockwise as two different, like clockwise and anti-clockwise are not same. Then it becomes npr upon r, this way, as I've already told you, right? So the next part is number of the circular permutations of n different things taken r at a time in clockwise. This same thing, but it is same this time, not different it is. So when it is not different, then again we have to divide it by 2. Yeah, because you see, if it is same, then you have to divide it by 2. You just have to use some common sense over here. Questions are very easy. You just have to remember this formula. This is very simple if it is not same. This is the case out of it. This that is same. That's why now we are dividing it by 2. If we mark number 1 to n on chairs in a round table, then m person sitting around is n factorial. If there are n chairs, the n people will sit on it. So how many ways n people will sit on it is n factorial. That was the very first, we have very first theorem only itself. Then this is, like I already told you, the sum of the combinations like nc0 and c1 is 2n. And when you're taking only even one, then it is 2n minus 1. Even if you're taking only odd one, still it is 2n minus 1. If it is instead of n we have 2n plus 1, so here it was 2, instead of here we will have 2n plus 1. Simple. Yeah, I hope you're getting it. Plus 1. And then if it is n plus 1, n plus 2, and this is remains same, and then it becomes 2n, and this is n plus 1, 2n, and this is n plus 1. Yeah, I hope you're getting it. This is important because this is different. You would not have studied it in anywhere. So just remember this one. Can you see? This one. If n is even, then the greatest value NCR is equals to NCR upon 2. And if n is odd, then the greatest value of NCR is equals to NCR plus 1 upon 2. I hope you can see it. This thing. Yes. Hello guys, so the next topic is finding the factor of a number. Suppose n is any number and you are representing it in this, you have studied prime factorization in class 6, 7. So yeah, you have to just do it in that way, in the form of prime numbers. And then you'll also find like 6 can be written into 2 into 3. 2 ka power 1, like that. It can be, so any number can be represented in the form of prime factors. Yeah, so an alpha, beta, alpha 1, alpha 2, they will always be natural numbers if it is a proper number. Now the total number of divisors of n, then we can find how many numbers will be the divisor of n number. For that you just have to add 1 to all the powers and then you have to multiply it. Total number of the proper divisors. What are divisors? Divisors, every divisor is a divisor. But if we are considering about the proper divisor, then 1 is never considered a divisor, a proper divisor. And the number itself is never considered a proper divisor. That's why we will subtract 2 numbers out of it, that is 1 and the number itself, and then it will become this. Sum of all the divisors we get using this formula, which is p1 alpha 1 plus 1 minus 1 upon p1 minus 1, p2 alpha 1 alpha 2 plus 1 minus 1 upon p2 minus 1, p3 alpha 3 plus 1 minus 1 upon p3 minus 1, like that. 2k. Some of the proper divisors, again to this only we will subtract number itself and 1. So the n is the number itself and 1 we are subtracting out of it, as you can see already. So now the number of ways in which n can be resolved into the product of two factors. I hope you understand. Like 8, we can write it like this, right? But if we have to resolve it into two factors, then we will write it like this. Okay, so this has been resolved into two factors. So how many ways you can represent? You can also represent it as 2 into 4 like this, but this is same. So here only one way we can represent it. We have to represent it into 2. So yeah, n can be resolved by these methods. 1 by 2 into 2 की power it was 3. So 2 it is coming, right? So yeah, we can represent it as 2 if it is not a perfect square. But if it is a perfect square, we can add one more thing. That's the only difference. If n is a perfect square, then 1 will be added to it. Similarly, this is for just 2 if we're resolving it into 2 factors. But if can be resolved in any number and can be resolved into 2 factors which are relatively prime to each number, to each other, then it will be 2k plus 1. 2 factors, the specification, a restriction we have given that the 2 factors should be relatively prime to each other. That will become 2k plus minus 1, 2 की power k minus 1. This is not that important, but yeah, it can be asked in advance and all. I don't recommend you to learn all these, because if you already tried practicing this question, you would be knowing that these are not as useful as you think other formulas. Okay. The number of the rectangles of any size in a rectangle of size this. Suppose this is the rectangle of size this, and then you have to find the number of rectangles again. You can make using that. So that's very simple. If it was p plus 1 c, again you are selecting 2 out of it, and then again n plus 1 upon 2. This is again just to select 2, any 2 points out of it. Suppose you have to make triangle, then for triangle you have to get 3 points. Are you understanding me now? Number of the squares of any size in a rectangle of size, this is the size of the rectangle, p into n. Then again p plus 1 number in the rectangle, yeah, p plus 1 c2 n, p plus n plus 1 2. This is what we will be doing, and it's simple. Right now this is for rectangle, but here we have to find the number of squares. For squares it's different. Square is complicated. That becomes n plus 1 minus r, p plus 1 minus r. Simple. I is equals to 1, r is equals to 1, and here it goes to p. You have to add everything out and then you'll get it. Now we'll be talking about the exponent of the prime p in n factorial. The exponent of a prime number in n factorial denoted by ep is defined as, suppose there is some factorial 500, and then you have to find there is a prime factor p. What will be the power? Can be represented as 2n, right? So this can be represented as this way, like 500, 499 also, for like that it will be very much, lot of prime numbers will come. So because it's a factorial, in that case we will consider, to find the p, we will consider this equation. Okay, that is the power. So yeah, here in this condition is a p, and we have been find the highest power, so it will be n upon 5. So suppose n was 500, so like with 500 upon 5 plus 500 upon 5 square 25 plus 500 upon 25 125. So like this you have to go through till p, till k, till then it gets divided up. Like if it stops dividing, then you don't have to go through it. Like it's completely dividing, and once time you will reach something greater than 500, that will not divide, so you have to stop there and just you have to add this one, and case the largest number, this should be less than, right? That's what I'm saying. Should be pk should be less than n. should be less than 500, and when you get there, just add them. That will be the highest exponent. You will get it, you will get the highest exponent out of it. So here's the chapter ends, but don't forget to solve these kind of questions, because there are very tricky questions. Like there is a bag of 5 balls, you've been putting 3 red, 2 green, like that, and then you have to take out 2 green, then how you'll be arranging it. These type of questions are very common, so just prepare yourself for these type of questions, because you don't know what will come. Though I'm taught you everything from rearrangement to the number of the squares, rectangles, integral solutions, factor of the numbers, everything, but still practice it out, because all the formulas will change once the question is changed. Like that depends on what kind of question, and every question has different formula. Believe me, I solved the questions of this chapter, and each of the questions had a different formula used. So you just have to modify your formulas according to the question, as I already told you. I hope you get it, and yeah, all the best. Thank you.